Good morning, everyone. This is Irish Almonte, and today I'm going to discuss sets. So, what are sets? Set is a well-defined collection of objects. By well-defined, we mean that given any object, we can definitely decide whether it is or it is not in the set. So, each number is a set called an element, a member of set. So a set has the associative property under a particular operation. If the result of the operation is the same no matter how we group any set of three or more elements joined by the operation. So a set is a collection of things called elements or members of the set which can be mathematical objects of any kind. It can be numbers, symbol, points in space, lines, or other geometrical space, shapes, variables, or even other sets. So ways of writing sets. So as you can see here for rooster A has an element of list out of all elements in the comma separated list. As you can see here, it is every word is separated by comma. So for example, rooster A is 2, 4, 6, 8, 10 in sequence. So for set builder, P is a variable condition for variable to be in the set. So for example, B is x is greater than 0 and x is an even integer. So for B, all variables should be greater than 0 and should be an even integer. If you can take a look at the rooster A, the numbers provided for this example are integer numbers that are interval by 2's. So for these special sets, this is an empty set consisting of no elements, which is there is no number inside. So for this is the set of natural numbers, which is the 0, 1, 2, 3, 4. And for this one is the set of integers, which is the negative 3, negative 2, negative 1, 0, 1, 2, 3. And for the next one is the set of positive integers, which is the 1, 2, 3. For this for the second one is the set of rational number, which is P is an element of Z and is an element of Z. For the next one is a set of real numbers. In calculus, we wrote the interval by negative infinity or infinity. So, so the next one is a set of positive real numbers. So in calculus, we wrote the interval of 0 to infinite. So for the next one is the set of complex numbers. As you can see here, we have positive, we have negative, and we also have invalid numbers. That's why it's called complex numbers. So what is subset? So in mathematics, set A is a subset of set B. So if all elements of A are also elements of B, then B is the superset of A. It is possible for A and B to be equal. If they are unequal, then A is a proper subset of B, then the relationship of set being subset of another called is inclusion. So set A is said to be a subset of C of all elements of set A also are represent the set B. In other words, set A is contained inside the set B. For example, if set A has X and Y and set B has X, Y, Z, then A is a subset of B because the elements of A are also presented in set B. So we have here power set and infinite set. So power set is given of any set of S and S. The power set of SS is the set of all subsets of the set SS. We denote the power of SS by PS. So finite set. Let SS be a set if there are exactly an n distinct elements is SS where n is a non-negative integer, then we say that SS is the infinite set. Cardinality of n can be rewritten as S is equals to n. A set is said to be infinite if it's not finite. So, ordered n tuple. So we define an ordered n tuple to be an ordered collection of the form. So we call that 2 minus 2 tuple is A1, A2, an ordered pair, and the 3 tuple is A1, A2, A3, which is an ordered triple. So in mathematics, a tuple is an infinite ordered list of n elements, and n tuple is sequence of n elements, whereas n is a non-negative integer. So there is only one zero tuple, so referred to as the empty tuple. So as an tuple is defined inductively using the construction of an ordered pair. So for the Cartesian product, a set that is constructed from two given sets and comprises of all pairs of elements such that first element of pair is from the first set and the second from the second set. So the Cartesian product of set means the product of two non-empty elements in an ordered way, or in other words, the collection of all element pairs obtained by the product of two non-empty sets. So as we can see here, let A, and be sets of the Cartesian product of A and B, denoted by AXB and AXB, by the set of all ordered pairs of AB, where A is an element of A and B is an element of B. So for the union is a set of theory of union collection of set and set of all elements in the collection. So it is one of the fundamental operations enough which set can be combined related by each other. So a nullary union refers to a union of zero set. It is defined definition equal to the empty set. So if AA and BB are two sets, then we define the union of AA and BB denoted by a union B to A union B to be the set of all elements that A are in AA and BB, or both are A union B. So for the intersection set can be denoted using by the symbol of looks that look like letter N, which is the intersection. As defined it above is an intersection of two sets A and B. So is the set of all those elements which are common to both A and B. Symbolically, we can represent the intersection of A and B as A intersection B. So for the difference is the set of one of important and fundamental set theory operations. So union intersection are the other set theory operation in addition to the difference of sets. The difference of two set A and B and gain set that consists of the elements of A that are not in B. So for the universal set, in this set theory, a universal set is set which contain all objects including itself. So a set theory as usually formulated, the conception of a universal set leads to Russell's paradox and is consequently not allowed to let U to be the universal set that is set of all possible objects in consideration. So that is it for today. So thank you for listening for my presentation. Again, this is the presentation for sets.